Lesson 2, Bipolar Transistors. Section 2.3. Input characteristic of BJT. Experiment 2.3. Construct this circuit. Note that a very large resistance RB of 100 kΩ is inserted in the base circuit. Typically, this resistance is several hundred ohms to several kiloohms. This high resistance is used for measuring the very small base current IB, which is on the order of 10 microamps. Set the signal voltage with an amplitude of Vm equals 200 millivolts. This amplitude is much larger compared to the 10 millivolts used in experiment 2.2. Measure Vs plus VBB, and VBE. Draw the graph of IB versus VBE. IB can be obtained by using this equation. This figure shows how to measure the voltages. The signal generator of the ADALM2000 can supply VBB and Vs. The W1 pin and the G pin are the output pins of the USB instrument. The DC voltage source of ADALM2000 can generate VCC. The V plus pin and the G pin are the output pins. Vs plus VBB and VBE can be measured by the oscilloscope of ADALM2000. The 1 plus, 1 minus, 2 plus, and 2 minus pins are the input pins for the oscilloscope. This is the pinout of ADALM2000. And this is the wiring of the transistor circuit. The transistor and the resistors are inserted into the holes of a breadboard. These are the connections for supplying Vs plus VBB. And this wiring is to supply VCC. The 1 plus and 1 minus pins are the input pins for the channel 1 of the oscilloscope, and the 2 plus and 2 minus pins are those for the channel 2. This photo shows an actual transistor circuit. These are the measured waveforms of Vs plus VBB and VBE. The horizontal axis represents time, measured in milliseconds. The vertical axis represents voltage, measured in volts. The oscilloscope data were saved into a CSV file, and the graph was plotted using Microsoft Excel. From the saved data, IB was calculated. This graph shows IB versus VBE. The data contained noise, primarily caused by the quantization error of the ADALM2000's AD converter. This concludes the answer to experiment 2.3. Now, let's examine these experimental results in more detail. This is an approximate exponential curve fitted using the least squares method. Microsoft Excel has a function for finding fitting curves. The obtained curve is given by this equation. Please refer to equation 1.1 in section 1.3, which is Fermi-Dirac probability function. I0 is 4.88 times 10 to the power of negative 8, and Q over MKT is 27.1. We can neglect the term 1, because it is very small compared to the exponential term. It is found that the approximate curve is in the form of Fermi-Dirac probability function. This means that there is a diode characteristic between the base and emitter. This is called input characteristic of transistor. These are samples of data from the fitted curve. From the samples, we find that, if VBE changes from 0.655 volts to 0.665 volts, then IB changes from 2.5 microamps to 3.27 microamps. The amounts of changes are 0.01 volts and 0.77 microamps respectively. Exercise 2.3. This is your homework. Pause the video, and answer the problem. Find the empirical constant M. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.